So I'm Douglas Forsström. I run the product team here at Hammerspace. And I keep getting asked, it's hard to deploy and get our product out. So as you can imagine, we end up doing a lot of demos and showing the product off. And so as we brought our Amazon offering out now probably a year plus ago, and we're bringing, by the way, our paid offering out here in the next week or two, the customers have really easy to deploy a product in the cloud, Amazon, Google, or Azure for that matter. It's coming very shortly. And so it's exciting that you can automate things. And I am by far not the guy that would sit in a large corporate environment to write a script to automate things, but I literally spent a few hours writing a script to deploy any size global file system, just to get the testing simple. And right now I'm just letting this run here for a second. This is practically real time, as it was recorded, deploying using CloudFormation Amazon, our product, and it's fully automated. You don't really do anything. You just literally kick it off, and you can click the Amazon GUI. You could probably use Ansible and a bunch of other automation methods. In this case, I just wrote a script so I can easily output whatever I wanted on the screen and get it in a generic form. But what I also did, and it can be done, is automate the configuration of it. And I'll show you this, what it looks like here in the product. And that makes it easy to deploy. And the whole point of a product, we don't expect to be hosting anything for the customer. The customer's data is too vast, it's too big, and it's too secure and too private that we're not hosting the service. But we need to make sure our product is easy to deploy and quick to deploy, so you don't sit in hours or days spending time deploying it. And I'm deploying here end-to-end. I think this took maybe about 15 minutes or so for a 3-site Hammerspace setup. And this could be across regions. This could be automating into existing. This is just showing you how easy it is to deploy it. I did the same thing about a month ago with a 32-site setup. By the way, officially we only go to 8 sites today, but pushing the limits is what we always should be doing. So I decided to go to 32 sites. And 32 sites took about 2 hours. So you can imagine if someone has a large environment and they quickly need to get Hammerspace up, especially when you can leverage the automation kind of just built into the cloud or their own automation environments, installing us and deploying us even in a large environment is not something that will take weeks to do. It literally takes minutes and hours. And you need to get maybe a little bit familiar to get the full end-to-end spectrum with our APIs. But that's the point of a REST API. We have APIs that allow customers to automate deployment and setup to any extent they want. And the whole point of today's demo was really to go through the global file system, the ability for us to really show access to data across many sites. And these sites can be very geographically dispersed. We have customers today running in between different countries in Europe, across the channel in Europe, into mainland Europe. We've done installations between California and Australia. So same thing across the US, between New York, San Francisco, and as well as down in Texas. So we've had our product in customers' hands for a while, and we've been exposed to what historically would have been very complicated scenarios for a global file system. And the way our architecture has been implemented and deployed has made this pretty straightforward. The way we separate out, like David mentioned, the data movers versus metadata replication and not tying data and metadata together allows us to very, very effectively handle sites that might be really slow from a even performance but latency perspective, and sites that are well connected together. And the whole architecture is designed to not always be in sync. It's an eventually consistent model. And I don't have a whiteboard, unfortunately, at home, but David does, so I'm sure we'll end up whiteboarding here in a minute. But that is the point. And what you see right here is obviously very simple. It's a 3-site setup in Amazon. I'm going to add an on-prem site from a data center in Utah. Amazon runs in Oregon right now, in US West 2. So to get an idea on what it would look like from a customer perspective. But the first piece is how do you access our global file systems? You have a dashboard. You have how performance characteristics. So one thing we get with our product automatically, it doesn't matter which protocol you use, is accumulated statistics on who's using what and what performance do you see. So this we elevate up into a dashboard that on the normal setups you'd see a bunch of IOPS and throughput being used. for a system that's actually in use. But you can navigate, you see health for all the components in the system. We have a widget on the right-hand corner that shows the connectivity between sites and so forth. So you'll keep an eye up on the right-hand corner here on the site numbers, because I usually flip between sites. When we go into a share, because, and I'll pause here again, our global file system is global per share. You can think of a share as a file system in a way. It's not quite that way, but that's where you can think about it. So, the metadata server itself, we call them Anvil. They are by themselves individual on sites. Obviously, they're highly available, and you always deploy an HA configuration and all that. But the site itself is an individual standalone unit. If all other sites go down, the metadata on that site is fully accessible. Any data you have accessible from that site is fully accessible in the file system. Nothing changes from an access model, or you're not restricted. So you can have many sites that are connected, and some could be down, some could be powered off, and that's perfectly okay. Unless they have the last version of data, it doesn't matter for any other site. And that's the eventual ecosystem model we picked that allows us to scale, but also allows us to operate under real production scenarios, not a perfect lab environment. But each site is an entity where you actually access the data. So you have, for each share, we in our product, you can see here, this is particular one, each site has its own NFS endpoints and SMB endpoints. Those are the official protocols we support today for production use. And we obviously integrate with Active Directory, and we have a common permissions model across NFS and SMB. So all the vanilla you would expect file access stuff is just there. Okay. And so each site you can access over various protocols. They all go through a single set of, it's not a single set of IPs. In a production environment, you would use DNS. For Active Directory, you would probably use some kind of Active Directory endpoints. We have more than one. You might use DNS round robin. You might use an F5 load balancer for NFS v3. For NFS v4, you don't. You just need to use one IP, and we will automatically load balance and make available data across multiple endpoints in the back end. So NFS v4.2 works a little bit differently than the traditional NFS. But so what you see me doing here in the video is literally going across to all the sites and just mounting the data locally. So I'm going to just show you what it looks like from bare bones up. So I have a Linux client running CentOS 8 something, and I'm just going to mount this using NFS 4.2. Functionality-wise, it's the same for any protocol. None of these data management tasks we can do have a protocol dependency, right? So live data mobility, locking, all these things across all the protocols just exist. So it's quickly going to go through and do this across all the UI, all the endpoints. I'm also going to show you, by the way, SMB access on-prem. So it's going to be a mix and match of the different protocols. And each site, again, individually managed. And so you manage objectives, like David mentioned, on a per site basis. So we're going to apply objectives as well in the demo to see data access and how that can be impacted by dealing with data placement a bit differently than in the past. So all of these being mounted using NFS version 4.2. On each share, on each site, you can also go and look at the replication details. And it's worthwhile to mention here, and this is a share that was just set up, and these things to settle over time. But the metadata replication is sent and received from all sites at all times. It runs at a periodic default is every 5 seconds. So we don't replicate every transaction as it comes in. We take a periodic approach where every so many seconds, and it's something you set up when you create the share. So you can go from, frankly, 1 second, which is a little bit close maybe for a large setup, to even minutes or hours. And this is something that could even differ between sites. So you could have a site that doesn't need metadata operations updated more than maybe a handful of times a day for whatever reason. You could have sites that are across the Hudson in New York that want to be as close as they can to make sure that you have easy data resilience across them. So one data point we show in our product is how this latency is plotted over time, right? And I just deployed this. I don't have multi-day output yet. But you can see that the receive and send latencies are generally a little bit different.
Do you need to? How do you consider things like file locks with an eventually consistent system? If there's changes happening to the same data in multiple sites, how do you handle all of that?
So the approach we took to make sure we have a scalable multi-site solution is not to do a a conflict avoidance, which is a global file lock server. I mean, there's something we might add in the future because there's some workloads that do depend on that. But what rather, we took an approach of doing conflict resolution when conflicts arise. So each side can operate independently, even when they're disconnected from each other. And if you are, let's say, working on the same file, or you create the same file at the same time, there's numerous scenarios where that could happen. What the system will do is automatically version the files. So depending on the scenario, and we can talk about that, I'd love for David to get on his whiteboard when we go through that part of the demo, to show you what that looks like in the different scenarios. Because we will either version the files and make sure you have a local version that is the same file name, but is known as different suffix on the other sides, which is pretty unique. Or in case of writing to the same data at the same time, the last writer wins, but at the same time, you also get versions of that file when that happens. And so let me go through that piece of the demo, and we can bring that back up and have David go through the whiteboard and those flows. But the only drawback with our approach right now is the fact that if someone does require, let's say, editing the same file on multiple locations at the same time, that's something we cannot support today. But every other use case where that doesn't happen, which is frankly so far most of them, we fit really, really well. And the only consideration when you deploy large clusters, so when I did the 32 site setup, I did that using a 20-second latency instead of a 5-second latency, just to give you an idea on what that would look like. It doesn't have to go to minutes or hours, even for large configurations. And the same thing on the other sites. You'll see that site's perspective, which might be a little bit different than the other sites, and that's okay. And you can also configure latency thresholds. So if something doesn't work to your what you specify, you can get alerts through obviously SNMP, syslog, and all the standard methods. So here we have the sites. They're all mounted. They're all empty right now on this. We create a single file, very, very simple, just to get started. You have a 10 megabyte file. Wait a few seconds. Remember the metadata latency, a few seconds, so you get to see files relatively quickly on the other side. So now I just had a very, very simple pause here. Create a single file, literally within seconds, that metadata is available. Now, we're going to do this at scale in a minute, where I simulate a lot more data. But that's how fast the metadata replication really works. It goes pretty quickly. Now, if the files aren't local, what will happen is that we will have to upload that file to object storage along the way. So here I'm reading the file on site number 2. So I created a file on site number 1, as you can see above. I'm reading the file on site number 2. And what happens now is that the file isn't local. I don't have a proactive policy to put the file local to site number 2. And I just created a file, by the way, on the other side. So let me pause here. And so what happens at that point is not only do we have to wait for me to get rights to upload a file, so there's a delay that we're requesting the client give up the file. Are you still writing to it? If not, you're done. Then upload it to object, and we use object as a means to get data from A to B. So one important architectural design we did is that we don't want to build yet another data replication protocol, not a port the customers open in the firewall, another thing someone has to monitor on the network. So we choose to use what we call shared object volumes. It's just object storage, frankly, an S3 bucket or an Azure bucket or a GCP native bucket, whatever you may have as object storage, as a means to get data from A to B, right? So what happened, why it took a little bit of a few seconds here, is the fact that not only do I have to request this data on metadata level, which happens pretty instantly, but I do have to upload a file to object and then download it to local NAS to serve the file out. And that object layer is really beneficial.
And Douglas, that movement is on demand only when like site 2 or another site actually requests the data?
Yeah, so the data placement, so metadata is everywhere all the time for the share. The data is only placed on a site either if you have an objective saying, hey, I need the data local, because my rule says any file that got modified in the last 24 hours, I need a local copy for whatever workflow I'm working on. Or any file with this tag should have a local copy. You can do many things. Or like what I just did here, which is really on-demand access. I didn't know I needed this file. I don't want to put this file on this edge site because it's 10 megs in size and I don't really want to waste space for it, but someone needed to read it. So we pulled it over, we read it, and by default, that file will only live on that site for a couple of minutes until it gets expunged again, unless you have an objective that says otherwise. Okay?
And it's accessing that data on a local storage device, or is it accessing that data through the object storage copy?
So any data we serve out in our architecture always comes from a local file NAS storage device.
Okay.
So we always rehydrate, today I should say, we always rehydrate data and then we serve it out over SMB and NFS protocols. What I'm going to do now is just append to the file. And what's interesting with that is that now I had a file that was created on site A, I'm appending to it on site B, and I'm creating a temporary file here just to, you can see I'm not the great speller always. And I'm going to read this file and just append to it. I'm dumping that file in memory, which is in /temp. And then I'm going to read from that file. I'm going to dump it append it to the end of file A. So cat to 10 megabytes, append it to file A. And then I'm going to go back and read it on the site that originated to make sure that the file. So ping-ponging of data is fully supported. There's no delay. So as soon as the metadata is up to date, we know that someone else has modified the file. We know that the copy we had local is no longer valid. So we don't need to resynchronize data, anything like that. The moment metadata comes in, which is literally seconds later, and I always wait a few seconds because sometimes you have local client caching phenomena and stuff like that. So I always give it a few seconds. You can see that the file had changed. So what's important with the system is that the customer generally never had to worry about files that are out of date. They don't have to worry about a sync process. Then the only thing that happens is the metadata comes in, and if there is no local file, you're going to catch it and get it from the remote system.
The question about basically the so those sites that you're actually mounting, you said that those are effectively local to each independent site. Is that like a physical piece of hardware? Is it a virtual machine? How does that actually work at each one of those sites?
Sure. Let me, I didn't share this part. What I did was, in this particular setup, I have 3 sites that are running in Amazon. It was just simple to automate that way to deploy it. And then I'm going to add a 4th site that runs in a virtual machine environment in Utah, where our data center is in outside Salt Lake. And in Amazon, each site is a metadata server. There's just an Anvil running on local EBS storage as metadata storage, nothing special. It's not the fastest in the world because EBS storage isn't the fastest in the world, but it's plenty fast enough for most workloads. And then I'm using the DSX node that has just spinning slow disk, ST1 disks on it. Mostly because I sometimes do scale testing and deploying SSDs for that doesn't really make a difference. And the beauty of this is that you can deploy many DSX nodes. You can deploy one DSX node with many EBS or ST1 or NVMe volumes. And the data can also be made resilient. So data placement is happening within a site, and data access is across sites. So you can say that I want data in this site to be mirrored across availability zones if you're really paranoid about your production site. Then I want my data on my second site to be my DR scenario, and all my data sits in object until I need it. So there's lots of choices to make, and the system will orchestrate all of this automatically. You simply set up simple objectives for it, and I'll show you some of those objectives here in a minute. And so the data placement is something that's completely driven. So if you want a system that is highly performant, maybe you want to do Amazon NVMe nodes and mirror the data synchronously across them and serve that out as your tier 1 storage. And then as the data ages, it goes back into cheaper, slower, or even archival storage types. All those are simple one-line objectives for us. It's very, very trivial to do those things. And it's more about what infrastructure you have available. You can automate placement, like David mentioned, using performance characteristics, or you can be more specific if you're a traditional, data management person, to go and say, I want this data on this volume, I want this data over here, and so forth. And our system, if it can't meet the needs, by the way, it will also tell you through what we call alignment. You'll have orange and red and green, and it will tell you why it can't align the data. So you may want to say, I want all my data to sit on super fast storage, and you have a petabyte of hot data, and you only have 100 terabytes of SSDs, and we can't deliver on that, and we will tell you. But what we will do is put the data that's active on that automatically, so you're not going to be necessarily left in the dark. So the setup is pretty straightforward. And this could have been Amazon, Google, and Azure. It's simply just logistically difficult to get it all necessarily together always in that order. So, but the product works across them all. And, so what we'll do here is to make sure that we can add a fourth site. So, one is I deploy 3 sites. I want to add and include my on-premise data in the cloud. So if I want to go and take, let's say, data I have on NetApp and Isilon and put that in the cloud, I don't necessarily have to go and use the vendor's tool for it. You simply just add the storage into our, in a read-only or read-write fashion, by the way, and I'll do a read-only today, and show how easy that is. So the first thing you got to do is just to make sure that this node can talk to the rest of the sites. And we do that by adding what we call a shared volume. So this is in a Utah site, as you guys can see I'm highlighting here. I'm going to go in and just add a shared volume. So what I did before this, and the only setup I did in this site, other than deploy Hammerspace, was to add, my various locals. So I use S3 min IO as a local object store because I don't want to send data to Amazon all the time. I have Isilon, NetApp, I have an Amazon S3 bucket. All those are valid storage systems that I can now take buckets from. So I'm going to grab the same bucket that I use for the other 3 sites. And we're going to get a warning here saying it's in use, which is expected because it's being in use. We're just going to add as a shared volume, which means now all the data going into this bucket is globally deduped. Okay, so I don't have to replicate data up there if the signature already exists. So adding a bucket is pretty quick. It takes maybe a few seconds, or 10 seconds or so. It'll pop in here. And now we're going to add a 4th site. So we're going back to site number 1. If you see up here, we navigate into site number 1. We're just going to go to the shared data. We're going to add a 4th site to it. So we're going to include the new site that just added in there in the metadata replication. Okay, so we're just adding it. This could be done from any one of the other sites. I just picked site 1. So I haven't done the Utah data center before, so I'm adding the credentials in for that Anvil. It could be any administration level user. We can test the connection. Everything looks great. Replication interval is 5 seconds, and we add it in there. And so, it takes about 20, 25 seconds. I left this as real time. I didn't edit this out to create a global share. And what happens now is that we set up a secure metadata replication relationship. So we encrypt all the metadata traffic, obvious reasons, between the sites. We I think we also even compress it. So, we try to minimize it. And you can see now we're done. So the 4th site is up. So if I navigate into my 4th site, I can see I'm in the Utah data center, and I go back into the share listing, I'll see now I have a new share called data, which is what existed on the other one. And if I navigate in, I'll see the data in there. So we're going to add existing data in this. We'll see this in a second. So we're going to add data from a NetApp and Isilon into this share. What will happen then is that the metadata from these operations are going to also be available in the cloud. And anytime you want to get to data in the cloud, you can do it by on-demand or by policy. And we'll end up doing both. So we're going to do an on-demand for sure from Windows. So here I'm taking an Isilon volume, IFS images, and I can pause here if it's going a little bit too fast, by the way. So we're assimilating the data. So this is a new concept maybe for some of you. So we can not only add new storage volumes into us, but we can also add existing data. We call that process assimilation. And assimilation can happen in 2 modes. You can add it in a read-only mode, which means we only reference the data. We will never write to that volume, but we can consume that data as read-write in our file system. And if you write to it, we will then instantiate mobility and put it on the read-write volume and so forth. So, but in this case, I've used read-only because 1, it's handy, and 2, maybe I'm using that share in my native environment of something else, and I only really want to get that data into the cloud for DR purposes, for some processing of the data I want to do in the cloud, for whatever reason I want to do it. I just want to get a copy of that data easily in the cloud using NFS and SMB as a way of accessing the data. So what we do is then we go into assimilation. We pick the source, which is going to be everything on that share. You can be very specific if you don't want to do everything. We put it in the data, and I'm going to put it in a subdirectory underneath the Isilon. So just to put a demo purpose, you don't have to. You can put it anywhere you want. I'm going to not log the progress. And if you want, you can also include all the SMB metadata. I don't have any on that data set, so I'm not going to bother. And now I'm assimilating it. So what I'm doing effectively is taking that Isilon volume and I'm merging that into our existing file system. And so if I navigate into the share now, I'll see I have all the Isilon metadata in there. And it goes pretty quickly, by the way. And there's only a few thousand files in the setup. It doesn't matter how much data it is. It's going to traverse the file system in the background. So even if you had 1 billion files, it'll still take about a minute for the user to just finish. And everything else happens on demand and in the background. And we're doing the NetApp the same way. Taking a NetApp volume. I think this is an old 7-mode system. We support 7-mode and C mode, obviously. I'm going to put that in a different subdirectory. Overriding the same files is going to be complicated, so I don't want to create conflict that way. So I'm putting it in a different subdirectory, and I'm going to finish that off. And now I've taken on-prem storage systems, put them into a global file system, and the metadata literally in a few minutes is available across on-prem and in the cloud. And to get to that data in the cloud, all you need to do is using those mount points I did earlier, you can get to the data.
How is this priced?
We price on capacity, so data under management.
Okay.
And so you can pre-purchase capacity using bring your own license on-prem and in the cloud. Or now starting I think next week, you can also go into Amazon and buy us, and there will be just regular Amazon pricing, as in you get billed for only the bytes, well, technically it's terabytes, I think, in Amazon, or gigabytes that you use. So, it's, and I should also mention in Amazon, not that it's a sales thing, but up to 10 terabytes is free. So anybody can use our product up to 10 terabytes without any cost from Hammerspace in Amazon, or Google, or Azure for that matter. So, it's easy to get going and use it. And if you don't exceed, then it's no cost from a Hammerspace licensing perspective.
Doug, I'm not sure. Let me make sure everybody understood what you just did, because this is something that the storage vendors can't even do between their own product lines. The ability to simply point to an existing networked file system and instantly create a writable clone of it that's usable without even having to wait to scan all of the metadata. Because our system is working through reference, we're able to simply set up the reference to that volume and then allow the user to have on-demand access to it. Even writing, we capture the writes on our side so they don't modify the original. So you're basically making a writable clone of an existing potential petabyte scale environment in what is immediate. And then you can set the policy that says, oh, I want this orchestrated to have redundant copies in the cloud, and it'll do that in the background. So you can immediately benefit from this data orchestration, consistent, unified access, simply by pointing to the existing file systems in an environment, and voila.
Thank you, David. Yeah, it's an interesting thing. I only showed NetApp and Isilon only because, frankly, they own most of the NAS market. You can do any NAS endpoint. So we have Windows file servers customers are using. We have Linux, ZFS appliances people have brought into our global file system. Anything that speaks NFS, and also if there's SMB metadata, we can include in the file system itself.
So I guess, and getting back to what David said, so is that writable clone sitting? Where is it sitting? I mean, if it's a site that had the NetApp solution originally and is trying to write to this, this global file system version of the file, is that sitting on storage in that site? Or if it's on demand copied to some other site, is it sitting at the storage on that site? Where does it permanently reside, I guess?
Each site has its own metadata service and its own data services. The data services are the movers and the like. So each site is its own management paradigm that manages the different storage assets that are available at that site. In other words, each site is first and foremost independent of the others and an independent resource manager of the storage on that site. So if I take a NetApp volume that has data on it, I can add that in a read-only fashion, touchless, we call it. You can do a touchless assimilation. And that volume is left pristine. We never touch it. The customer could continue to use it directly, but that data is reflected in Hammerspace metadata and can have policy then placed on it in the form of objectives that state how the data should be placed across the writable assets on that. So this presumes, of course, that you have some writable storage at the site to hold those changes to it. That's separate from the read-only file system that you're assimilating from.
I got it.
Other sites may have policy to put the data on their site as well. And then the data would get moved to those sites and stored on them as well.
Quick question here. So what happens if my, let's say, read-only file system, the NetApp one, changes? Yep. So I need to add additional files. So how the changes are reflected in
That's a great question. So we support a reassimilation where you can rescan the file system on the presumption that maybe modifications have occurred, and we adapt to those. So for example, this law firm I was talking about, they are using NetApp as their file service for their own, for their attorneys and paralegals. And because we're a new vendor and we're still proving our stripes, they want to continue to use the NetApp as the principal storage for that. So what they do is they make a snapshot in the NetApp every day. And then we reassimilate the next snapshot in the sequence. And then in our environment, we create a snapshot that parallels it. Basically, we're extracting the snapshots from the NetApp and recreating those snapshots in the storageless paradigm, where policy can then place the data into object storage on the cloud using their encryption keys. And now they have a way to immediately recover from a ransomware event because they have data encrypted, object locked in the cloud, and separate way to interface and failover to it. But to do that, they have to be able to adapt to the changes that occur on a daily basis, ongoing basis, to that existing NetApp. And the way they do that is by a trailing snapshot, so they can get very consistent points in time of where they capture that third-party volume.
My question is then, do you have a way to automate this? I mean, like, can you intercept something from the original storage, a message, whatever, so that you can...
In their case, they're doing it every day, at the end of the day, making sure we have a current replica from that day. And they're using snapshotting on the volume to provide that consistency point. And all of that is automated in their environment to do that on a daily basis. If you want something more live and adapting to changes, the recommendation is to pull the data in and have it be served from Hammerspace. We're doing that with them because they're still using their NetApp as the principal storage. If you want something that's more interactive, you would do it all through Hammerspace directly, and then everything adapts across sites granularly to the changes that are occurring. So another problem that this law firm has is that they're different. They have offices on the East Coast, offices on the West Coast, offices in Europe. Their file share environment is only located on the East Coast. So they get terrible access from the West Coast. They get terrible access from Europe. It's unusable, even though they have a WAN accelerator.
On this site, we have placement of data in there. And part of what we talk about is how do you get data local? How do you make sure that you want the data you want in a place? So here, what I'm showing now, literally, it literally is real time when I recorded this, is where you get that easy to get their data from on-prem into the cloud. Now, here I'm taking a Windows client on-prem in Utah, navigating into that share, into that mount point using SMB, right? And I'm going to simulate kind of like a rendering workflow where you create data online on-prem, just concept-wise, and then you use the cloud to render it. So use resources. Just what I think it was Enrique mentioned. We have customers that are concerned about latency between their client and their rendering. So get the data as close as they can to their client, to the user of the data. And obviously this is a simple text file just to illustrate the workflow. And then use the resource of the cloud or your data center for that matter to do the compute. And I'll pause here for a second. I pre-created a bunch of standard objectives that are available as part of our installation, is that you can just use for placing data. So what David mentioned earlier about objectives, they're just literally single-click things that you apply, and the system figures out behind the scenes all the complexity that generally would have been known with that. So in this case, I'm going to say I want the recently used files to have a local copy. So it means that if I'm working on the data and I say I have a collaboration, with someone else in a different site, maybe we're working often on the most recently used data. So you're in California hours, I'm working on the data. Then when Europe comes online, they start working on the data. So they need local copies when they come online in the morning. They don't want to sit there and wait for data to be copied and all that. This is all very easily managed with objectives. You just say any data is recently used, and I'll show you what that looks like. It's a one-line thing. Make sure you have a local copy, and the local copy will sit on the storage that is either fast, slow, efficient, whatever you want it to do. So everything is orchestrated across sites and also within the site itself. And you can see it as a lot more to objectives, but this whole session is not on objectives. We're going to move forward beyond that. But objectives are a key part of our architecture and product. So you're going to apply that on the whole share. So it's going to apply to all the data recursively in that share. And it doesn't matter what data is. Let me show what objective looks like. And so you can create and edit these things. This happens to be a one-line thing that I created. It says that if someone has last used the file, last use age is a metadata concept for last using it within the last 2 days, then keep it online. Keep it online means give me a local copy. And this is just a simple one. You can make a lot more specific one. You can say I want the copy on fast storage for an hour, then I want the copy on slow storage for the rest of the time. So there's a lot more to it than you can do with objectives. This is a very, very simple one. Just to illustrate the point, it doesn't have to be complicated to get a global file system into production and using your data across many sites. You don't have to have a science degree in getting it done. You just simply click it.
So Douglas, I mean, having all this stuff available at the UI is pretty interesting, but is there some way to programmatically use this sort of thing and to do all this stuff?
Totally. In fact, that whole beginning you saw me, that's using REST APIs to do this whole thing.
Okay.
I haven't typed a thing other than typing that path earlier. I haven't typed a single thing in an actual UI. So our whole product is based on REST APIs from a management perspective and allows you to do everything you do in the UI and frankly a bit more using automation. And the whole thought is that things should be automatable at any point, so you don't have to go and you click the buttons or react in time. And this kind of goes into even maybe the performance question of when you have a performance problem. Are you going to get an alert and then a button to click to fix it, or will the system automatically adjust it? And we fall much more in the latter, where we adjust and adapt on demand than sitting there waiting for user activity to user administration action.
Okay, thanks.
And especially when you talk about data at scale, we don't expect anybody, frankly, to sit and click and do things in our UI. It's supposed to be automatable and automated. So this file over here, and this the long awkward pause in the demo, right? So what you saw, and I actually cut out maybe about 30 seconds. So let me talk about this, and maybe David, this might be a good whiteboarding thing if you want to clear in the whiteboard, how it works when files are locked and worked across sites. I'll give a brief overview. So when you create a file on a site, we give you out what we call a layout. We give you out the rights to work on that file, right? And you get that by default for 30 to 45 seconds. You continue to work on it. It continues to just be yours. You can think of it as conceptually like a file lock, right? You're using that file right now. If I, on another site, request that file at that point in time, let's say for write access, I will be waiting until you're done on the first site because you're already using the file. The metadata knows the file is in use, and there's no point in versioning the file at that point because you can't. The metadata knows the file is in use. You got to wait. So what you see in the UI here, and I cut out 30 seconds delay, when I align data locally, if the data had just been created on the other site, it'll take about 30 seconds to a minute before that data can be uploaded to the cloud and then made available locally. And this is before any snapshots, right? So snapshots changes things, and I'll talk about that in a second. So that allows the system to work on files locally without having to worry about files being out of date anywhere else when they're actually actively being worked on.
Question about that. And this kind of, as you mentioned, it's like kind of like locking, but not locking. One of the areas where, locking was kind of an issue, especially when you're talking about disparate sites, is what happens when that site goes down and it's got a lock on a file. Is there any way to globally clear that, or to globally, kind of get that alignment back in line?
So most important concept is that the sites operate independently first and are coupled second. If the last version of a specific file is found on another site, then it'll wait until that file is closed for write before it's retrieved. So the only interlocking between sites is when the file is hasn't got a local copy and you have to go to the other site to get it. So it's a little different than locking, because if I do have a copy and we were disconnected, I'm not aware that the other site might have gone on to make modifications and that he might have yet a newer version of it. That doesn't block him from using the older version that he has, and maybe even modifying it in conflict at the same time. So this is why it's a conflict resolution, not a conflict avoidance scheme. What happens when you modify the exact same file while they are disconnected from each other is that you get two versions. And the prior version shows up in the snapshot realm as a prior version. And every time there's a change, it'll show up as a prior version. So while the last writer wins, you don't lose any other modifications when they come back into connection with each other, and it resynchronizes those files.
Great.
So let me just show you the very related to that on how the locking actually works. So here, let me show you this. So here's what happens when you create multiple files and multiple sites. Very, very quickly. So in this case, I'm doing a creation of in the same direct, in the same different sites, and creating the same file name in this name file, and writing a random amount of data on it, so we can see 3 different file sizes. So this just happened. And it takes a few seconds or whatever, let's say 5, 10, 20 seconds for the metadata to synchronize up, realize it has conflict. So there's a bit of a delay when you're doing ls-l, and that's okay, because you're going to be working on your local file anyway. So it's not like there's a risk of data loss or anything. You work in the file you have local. But so if you're doing ls-l, what you'll see here is that the first time I do it, I'll see the same file name, and you're like, oh, that's confusing. I'll do it again. And now you see the versions, the metadata sorting itself out, and you see the versions of this. So now you see that I have a local file here from site 3, main file, and I got 2 versions of it. This one I created the same file on 3 sites at the same time. So I intentionally doing conflict. And that's kind of how it works. And that's kind of where I wanted to wrap up the naming, because now you get, not only do you have snapshot copies when you write to the same file at the same time, but also if you create the same file, the system figures that out and versions the file and gives you also the information on where the file came from.
One interesting point on that, Doug, is that each site can have their view of the 3 conflicting files, and each site will keep their own truth that their file is the file, and that the other guys are the ones that have the alternate versions. That way, there is no you don't get things yanked out from under you when they recombine. Each site will maintain their own view of their truth and show the alternatives. And as soon as you remove the ambiguity by renaming one or by deleting it, as soon as the ambiguity is no longer there, then the suffix that qualifies what site the other things came from disappears. So basically, when you're faced with an ambiguity because the same thing exists or was created at both sites, then the suffix is added to disambiguate it, but your own copy doesn't have the suffix. You are just the file. It's everybody else's that's the other. And everybody has that alternate view of the world, and so they can continue to operate until the ambiguity is gone. It's a very powerful way to deal with collisions as opposed to binding your sites to where they all have to be running and in communication with each other. We view this as extremely powerful for edge computing, where one of the main principles of edge computing is the ability to operate with sites being isolated and offline from others.